Further Solutions Academy. Further Solutions Academy. Help us to share to your friends and also subscribe so that we can do more, we can see more of us. Once again, this is Further Solutions Academy. Further Solutions Academy. Okay, in this video, I want to be walking you through Trigonometry Part 2. We have done Part 1, which we talk about the previous video. We talk about special angles, how to use some logic to solve that, and we talk about so-called, logic behind that so-called, and once again, now we talk about complementary angle and so on and so forth. But this angle, I want to be walking you through all this. The first one is what? Identity trigonometry. Let me just put an angle trig. Now, and the second one is compound angles formulae, double angles, and nature of trigonometry graph. Now, this is at the end of this video, you must be able to understand all this. At the end of this video, you must be able to understand all this. But before we proceed, we have to understand something that I supposed to mention last video that I did not mention. Now, if I have, for instance, I'm talking about sine minus 690 degree. Somebody asked me to find this type of question. It's solvable. It can be solved. How will I solve it? What I'm just going to do is that this particular is beyond what? 360. It's beyond 360. What I will just do is that what? I will add what? I will add this particular angles to what? To 360. Minus 6 plus what? Plus 360. Which whatever I have, which is equals to what? It should be 330 degree. Now, 330 degree is in range of what? Is in range of 360, which is from 0 to 360 is in between. I can answer that what? Sine. This is minus, sorry. Sine minus 90 degree, which is out of the range, can be equals to what? Sine minus 33. I think, what are the quadrants? I think we have explained the quadrant of it. The quadrant of aspect of it, it will be what? Between the what? Sine negative, negative. Is it negative in what? Sine is negative here. It means it will be positive here, positive here. It will be, now it can be here, it will be between 0 to what? 0 to 180. It will never be in what? 180 to what? To 360. Because sine is negative here, sine is negative here. And so on and so forth. If I have another one, okay, for instance, if I have, let me look for the one of cos. I have cos minus 840 degree. Now, if I should work on this particular angle, now if I double 360, now if I double 360, it means 360 times 2. It will give me 720. Now, this 720, I can use to manipulate. I can see that what? Minus 840 plus what? 270 equals to what? When I minus this, 20 and what? 1, it should be 120. Now, I think it will be 120 degrees. 120 degrees. Now, since I have 120 degree, I can now say that what? Since I have 123, degree, I can say that what? Cos minus 840 can be what? Cos minus what? 120. This is minus. I can now solve and solve and solve. That is all about that. Now, also, another problem can come up before we go a bit deep, because this thing, they are very important. You have to understand them. Another thing can come up if something is given to us to solve. Okay, let me just spend that for now because I will try to, maybe there will be part 4, part 3 of this trigonometry, which is problems on trigonometry. Trigonometry. Now, let's move on to identity of what? Trigonometry. Identity. Okay, this one is very, very important in aspect of what? Advanced mathematics. Now, it's very, very important from here. I have my theta. This is my of x, I mean of y of x. Now, from our Pythagorean theorem, this can be 1. Let it be 1 because it's a radius. Now, from our Pythagorean theorem, I can see that what? X squared plus y, y squared plus x squared equals to 1. Now, don't forget that it has been proved earlier that what? Hence, my y equals to sine theta cos y, x equals to cos theta. We have done that in our previous video. Now, we have done that in previous video. Now, since that sine square theta plus cos square theta equals to 1. That is very, very important. It means I can use this one to represent this particular aspect. Sine square theta plus cos square theta equals to 1. I can use that to represent the. Now, that is number 1. This is very important. Now, if I want to proceed, if I should divide this equation by what? Cos theta. Divide all by what? Cos theta. Square theta. Now, I will have cos square theta all over sine square theta plus cos square theta all over cos square theta equals to 1 all over what? Cos square theta. Now, this will give me cos, and which is going to be cos square theta plus what? 1 equals to what? Sec square theta. Now, it means my sec square theta can be represented by what? By this. And also, my cot square theta can be represented by what? Sec square theta minus 1. And also, my 1 at this point, I can also represent my 1 as equals to what? Cot square theta plus, minus sine sec square theta. All can be represented. Now, they are all what? Identity. These are all identity. They are all identity. Now, let me move on. If I should do the same thing, you can do the same thing on your own. Divide all through by sine. You have the same thing. But from here, divide all through by sine, you generate another identity like that. Now, from here, sine square theta can be equal to 1 minus cos square theta. And also, cos square theta can be equal to 1 minus sine square theta. Now, they are very, very important. They are very, very, it means they are all identity. Now, that is all about identity. You can do the second part, divide all through by sine square theta. You also have something very good. At that time, you'll be having tan square theta. Let me quickly do that. If I should divide all through by what? Tan square theta here. Now, I will have 1 plus tan square theta equals to what? This one over sine is what? Is cosec square theta. Now, since I have that, I can say what? My tan square theta can be equals to cos square theta minus 1. And also, I can say that what? I can also say that my 1 can be equals to what? Cos square cosec square theta minus tan square theta. And so on and so forth. All these things are very, very important in advanced calculus, in advanced integration and differentiation. Now, That is all about that on trigonometry identity. The next one is compound angle. Now, that compound angle is very just I will just state the formulas and perform some little operation on it. If I'm talking about compound angle, we are let me just if I have sine A plus B, I have cos A plus B, and the last one I have tan A plus B. Let me plus or minus, plus or minus, plus or minus. Now, if I have this type of problem, they are compound angle. There is proof for it, but I don't need to prove it now. Now, what I need to do is, my sine will be what? Sine A cos A plus or minus cos A sine B. The angle will change. Can't you see? The first one, B. Why this one, why this one is position of what? Of A, and what? The angle change. Now, why this particular, the sign will remain the same. Now, if I have this, I will to be what? Cos A, cos B, minus plus sine A sine B. Sine A sine B. That is all about that. And the last one, which is tan. My tan is always very complex. Anything about tan, you have to be very careful about tan. My tan will give us what? Tan A plus or minus tan B divided by 1. Now, this time around, 1 minus plus. It means minus will be down if it is plus up. Okay, which is going to be what? Tan A tan B. That is all about that. That is all about on compound angle. Now, these are compound angle. I don't need to go far on it, but there will be a part 3 of this video which I will try to bring out some problems that will be of help. Now, if I should continue, okay, let's move on to double angles. If I should talk about double angles, now my double angles. Now, if I talk about my double angles, now my double angles, they are always if I have sine A plus A, surely this one, okay, let me start from, is double. Sine 2A can be expressed as sine A plus A. Back to this. Now, which if I have cos 2A can also be expressed as cos A plus A. Now, if I have tan 2A can also be what? Tan A plus A. Now, just double of the same thing of what is here. Now, what you need to understand is, at this point, I can call this as what? Sine A cos A. Okay. Plus, so I will see how this thing relates. Plus cos A sine A. It remains the same. Which also the same thing as what? 2 sine A cos A. That is for that. Now, this also, if I have this, it will be cos A minus sine A sine A, which also implies cos square A minus sine square A. And also, this aspect, I can have it will be tan A. Now I can say that what tan A plus tan A all over 1 minus tan A tan A, which also implies what 2 tan A all over what 1 minus tan A square. Now that is double angles. Now I can also generate half angles. I can generate half angle. If I should work on my half angle, it means let me quickly put that in blueprint. Now if I should work on my half angle, now my half angle is just like angle. Now my half angle is also the same. If I have sine A, I can express my A as what? Sine 1 A all over 2 plus A all over 2. I can do that and do that and do very good, which I will express this as what? Half. It means the angle will be what? Half. Now, that's all about half plus half is equals to 1. Okay, let's move on to the next one is we have covered identity, compound, double, and the next one will be, let's move on to nature of what? Trigonometry graph. Nature of trigonometry graph. Okay. Nature of trigonometry graph. Nature of trigonometry graph. Now, if I should talk about the nature of trigonometry graph, now, basically, the ratios are what? Sine theta, comma, cos theta, comma, and tan theta. Now, in our previous video, I've shown you how it works. This one, once this one is moving forward, this one will be moving backward. But this one will cut off at the point. That is why at tan 690, it will be undefined, to be cut off. Now, to be infinity rather. Now, not undefined, it will be infinity. Now, if I should work on sine theta graph, just to show how it works, you can test it when you get to your house, get any problem on sine graph. Now, it will be something like this, something like this. Now, my sine graph is always like from origin. And moving on like that. Option. Now, that is my sine graph. This is my sine graph. This is how my sine graph look at. Sine graph. Now, but in the case of my cos, if we are referring to cos graph, that is sine graph. Cos graph is always like this. It will be like this. It will start from 90. It always starts from 90, which is my cos graph. This is my now cos graph. Now, but my tan is very, very funny. It will cut off at a point. It will surely cut off at a what? At a point. Now, if I'm referring to my tan, which tan? My tan is always like this. My tan is always like this. It will cut off at a what? At a point. That is how tan graph is. Now, this is Further Solutions Academy. This is Further Solutions Academy. In our next video on trigonometry, we'll be working on problems on trigonometry. Problems on trigonometry. Okay. Thanks for watching.